This is a round 2 question, a set of DI, which is based on set theory somehow. It is given that in the election for the post of General Secretary of a university, 10 students, namely P, Q, R, S, T, U, V, W, X, Y, Z, were contesting. The university had a total of 200 students. Each student was given a sheet of paper on which he or she has to write the name of the candidates of his or her choice. Each student could write a maximum of 3 different names on a priority basis. The first name as his or her first choice, second as second choice, and third name as the third choice. Every student had to write at least one name on the sheet of the paper. The following bar graph represent the information regarding the number of times the name of each of the 10 candidates were written on the sheet of the paper. So one thing is clearly written here is that a candidate or a student can write one name, two name, or three names, right? And this bar graph gives me the number of times a name appeared. So if I add all these values, 44 plus 30 plus 26 plus 37 and so on and so forth, it will come out to be 363. Right. Now, if I assume that there are a number of people who wrote exactly one name on the sheet and B number of people who wrote exactly two names on the sheet and C who put exactly three names on the sheet. So one thing is very much sure that A plus B plus C has to be 200 total number of students, and using the set theory concept, A is the number of people who put exactly one name, so total number of names written is A. Total number of names written by B students is 2B, and similarly by C students who wrote exactly 3 names will be equal to 3C. So A plus 2B plus 3C will be equal to nothing but summation of all these values, which is 363. Right? So this is nothing but 363. If I subtract first equation from second, I'll get B plus 2C is equal to 163. And if I subtract the double of equation 1 from equation, if I subtract second equation from double of the first one, so I'll get A minus C as 37. Right. So what can be the minimum and maximum value of A, B and C? So you can see that A, B and C minimum value and maximum value. So using this equation, I can see that the minimum value of C can be 0. Corresponding value for A is 37. So I can see the minimum value of A is 37. Right. Similarly, when you put C equal to 0 here, this equation will give you B equal to 163, which will be the maximum value of B, because here the summation of two numbers are constant. If C is minimum, B has to be maximum. Right. Similarly, if we see the minimum value of B here, so B cannot be 0 in the second equation, because if B equal to 0, C will not be an integer value. But B and C has to be integers here because these are number of students. So the minimum value of B is nothing but 1. So when you put B equal to 1, C will be equal to 81 and A will be equal to 118. So these are the minimum and maximum value of A, B and C. Point to remember here is that these values form one set and the remaining 3 will form the another set, right? So this first question is asking me how many of the following are not possible values of the number of students who wrote exactly one name on the sheet. exactly one name means A. So which value is not possible for A? So you can see that value of A lies between 37 till 118. So 36 is not possible, 35 is not possible, 119 is not possible, 109 is possible, 121 is not possible, 118 is possible. So there are 4 values which are not possible. So the correct option is option D. Next question. What was the minimum possible number of students who wrote at least 2 names on the sheets? At least 2 names means this plus this, and we have to minimize this, right? So you can see the minimum value of B plus C is 1 in this case, right? And the corresponding value of C in that case is 81. So when B equal to 1, C equal to 81 is the minimum value of B plus C, which is nothing but 82. So the correct option here is option C. Third question is asking me what could be the maximum value of the sum of the numbers who wrote exactly one name and to that of those who wrote exactly 3 names. So check the data again. Exactly one name is nothing but A, and the maximum value of A is 118. Maximum value of C, all 3, is 81, is nothing but 199. So for this question, the correct answer is option C.